Can you hear me, Lane?
Yes, I can hear you.
اوكي. طيب تاني بنقول الرياكشن بتاعي ما بين النيتروجين مونوكسيد بسم الله والرياكشن بتاعي بيعتمد على اثنين رياكشنز equilibrium fast reaction و the other one goes to completion it's a slow reaction. مش عارف انا عندي تعمل ديسكونكت للاوديو هنا disconnect الاوديو بس مش بالظبط. طيب الريت اوف رياكشن بيتحدد بالمين؟ بالسلو ولا بالفاست؟ the slow one. the slow one. طيب اللي انا سميتها rate determining step وبيعتمد على المولر كونسنتريشن بتاع الرياكتنتس. يعني ايه؟ يعني ال NO Br2 plus NO تديني ال N2Br. يبقى الريت لو هيبقى كام؟ الريت لو بتساوي ال K لل NOBr2 اللي هو الرياكتنت الاولاني والرياكتنت الثاني. مستر احنا قلنا there is no relationship between the number of moles and of the reactants and the coefficients except ساعة لما اتكلمنا المرة اللي فاتت على مين؟ على السلو ستيب فين؟ في الميكانيزم رياكشن صح؟ مش احنا لسه قايلين اهو NO2 هنا كان كام مول؟
Bimolecular, 2 moles.
That's why we put the reaction as NO2 squared. So the only way time that I'm gonna use the coefficients of the reactants to explain the rate law is as a slow step of a multiple step reaction. So this is a slow step of a multiple step reaction. The rate is equal to K. This is 1 mole. So it will be to the power of 1 of that reactant and 1 mole. So it's to the power 1 of that reactant. At the same time, this NOBr2 is an intermediate. So it goes inside this reaction. صحيح ان هو بيحدد الرياكتنت بيحدد الريت من هنا and it also determines the rate here. طب اذا كان هو في حته منه fast shall I depend on the fast and leave the slow؟ لا، يبقى الريت اوف ذا رياكشن في حته منه fast جدا هيأثر كتير قوي على الرياكشن، هيخلي الرياكشن much faster. خلاص؟ زي ما يكون the example is that I'm saying okay I have 2 people to bring me a cake in the party and I choose 2 of my friends to bring me a cake in the party. So the first one is a slow one and the second one is a fast one. Okay, then I'll tell them okay we cannot make the party because the slow one didn't bring the cake. وعلى يميني قاعد مين؟ the fast one, she already bring the cake, so I cannot say that we cannot make the party start. The first one already came and brought the cake, so I can depend on this one. So I cannot ignore the presence of NOBr2 in the fast reaction. يبقى لازم أدخل ال NOBr2 rate inside اللي جاي من الفاست ده جوه الريت لو بتاعي. So I have to include the part which is an intermediate, especially because it is an intermediate in the fast step. والكونسنتريشن بتاعه ما اعرفوش. طيب هستخدم الايكوليبريم اكسبريشن من الفاست ستيب علشان اشوف ال NO وال Br2 ازاي؟ I will say like that. الايكويشن بتقول لي in the first one NO plus Br2 is in equilibrium with NO Br2. يبقى الريت بتاع الفورورد بيقول لي الكي فورورد. وهي الرياكتنس بتاعت الكي فورورد ال NO وال Br. انت قلت ان دي ايكوليبريم والايكوليبريم الريت اوف ذا فورورد از ايكوال تو ذا ريت اوف ذا باكورد. يبقى كي باكورد. مين الرياكتنس المره دي في الباكورد؟
NOBr2.
NOBr2. This is an equilibrium reaction. In the equilibrium reaction we know that the rate of forward equal to the rate of the backward. طيب انا عايز اخد ال NOBr2. ليه انت مهتم بال NOBr2 يا مستر؟ هو ده الايكوليبريم اللي انا جاي ادور عليه. انا جيت هنا علشان ادور. This is the one that I came looking for. This is the one that I came looking for. I want to incorporate this one in here. So again, just to summarize, the equation is dependent on the slow step, but because one of the reactants or products of the reactants in the slow step is involved as an intermediate here and here in the fast, so it's in the fast step, I need to explain what's NOPR2 with its speed, that it brought from the fast reaction. That's why I will keep it aside here alone. So I will say it's equal to the K backward divided by, again, I said I will put it on the other side. So I'm sorry, the K forward. خلينا نعملها هنا عشان ما نتلخبطش. So as not to be confused. Here زي ما كنا عاملينها. Oops, I want all of it here. Then I will say NOPR2 that I'm interested in equal to K forward, concentration of NO, concentration of BR divided by K backward. This is what? This is NOPR2 that's represented by this concentration. Now I will go back to my main equation. It's equal to rate K. Mister, I cannot use the K concentration here only. Why? Because this is only the slow step. It's still involved here. So remove this one and bring this one instead. I will remove this one and bring this one instead. It will be K. Put that one here. It's equal to K forward, NO concentration, BR concentration divided by K backward. And what's remaining? This one, NO concentration. So what you did now is that you included the two equations together. Included the slow one, which is the rate determining step. So practically, what did you use to make the rate low? The slow one, except for what? Except for the intermediate. Except for the intermediate that was included in the past. Did you understand what I said? Continue, Elaine.
Yeah, I understood.
Okay. Then I need to further change this one. This will be NO squared. So I can remove this one, NO, 2 times and make it NO squared, so?
Yeah.
I'll remove here and make it NO squared. Now, when I say the rate of that one, K1, this is K forward, and this is K backward, and this is the rate of the reaction. So I can say like that, this is the K. Where is the PR2? Where is this PR2? It is PR2 or PR. Why is this? NO, PR2 or PR? NO, PR2, so when we copy it wrong. It's PR2 here. And it's PR2 here, and PR2 here, and PR2 here. So I will say it is NO squared PR2. Then I can cancel this one with this one. What I can cancel? The K of the forward with the K of the backward with this K. This is the I can say this is the combined rate constant incorporating K and ratio of K backward to K forward هم كلهم. So I will cancel تاني. أنا عندي ال K ديت. This is the K and this is the K forward and this is the K backward. So I can remove this one. I can remove this one and a ratio of forward to backward and say something new called K dash. What is K dash? The K dash is what represents everything. The K of this one and the K of the forward and the K backward. It will be one constant for all of them. And put now NO squared and PR2 to the power of 1. This is the new rate. يبقى أنا شلت ال K اللي بتاعت الرياكشن اللي هي السلو، وشلت الفورورد والباكورد بتاعت الفاست، وحطيت واحده كي بس سميتها الكي داش، دي بتعبر عن الريت كونستانت بتاعت كل رياكشن. يبقى بقى عندي كي ان او سكويرد وبي ار 2 هي ديت اللي انسرز بتاعتي. طيب اني واحده من كل الانسرز بتاعتي will be the right one؟ that's كي ان او سكوير بي ار 2. so كي ان او سكوير بي ار 2 اللي هي نمبر دي. اوكي طيب let's see the next question. الفايل قصتها. need just to practice this one multiple times عشان نعرف ايه يبقى سهل علينا. I think my file is not covering for some reason. اختراع على وجه الأرض. حكاية الكلاود سيفنج ديت بصراحة شيء عذاب. مش عارف. الواحد محتاج فايل ويقول لك لا مش عارف أعمل لك داونلود. طب يعني أنا اللي خليك قفلت أساسا. أوكي. think the cloud is downloading other files. هو قرر إن هو يطنش. uploading. لا مش عايز upload دلوقتي. please stop uploading now. stop uploading now. seriously يعني بصراحة this is not funny. Okay الحمد لله. طيب the rate constant for a certain chemical reaction at 25 is 9 multiplied 10 to the power of 5 ما اعرفش كام. which of the following must be true regarding this reaction? This is the value 9 multiplied 10 to the power of 5 L2 and mole minus 1 and second mole minus 2 and second minus 1. This reaction is slower than a reaction that has a rate of constant of 9 liters squared mole minus 2. The first one was L2 mole minus 2 second minus 1 and this is 9 بس L2 mole minus 2 second minus 1. ولا الرياكشن ده is exothermic. انا مش ازاي دوت يكون يعني slower than. how come this one is bigger number and this is smaller number and says so this is false for sure. طيب this reaction is exothermic reaction. الله عليك. يعني واضح انها exothermic صح؟ مش كده ليه؟ باين انها exothermic جدا. شكلها
Yeah.
لا بيقول انها
100%.
100% ماشي. The rate of the reaction will decrease with increasing the temperature. برضو مش فاهمين يعني الكلام ده بيجي منين. The reaction order is 3. تعال نخش في الجد بقى. انت بتقول الرياكشن order is 3. يعني ايه الرياكشن is order is 3؟ يعني الريت بتساوي K، وبعدين عندك ايه بقى؟ هل
still
هي
the same.
3 ولا الريت بتساوي مثلا K A 2 and B 1؟ تعال نشوف في الحالة الأولانية. في الحالة الأولانية مثلا، أو ممكن يكون عندك K A 1 B 1 C 1. 3 حاجات دول ينفعوا معايا إن أنا يكون عندي الأوردر بتاع الرياكشن 3، صح؟ الحالة الأولانية what is the unit will be for K؟ will be rate over A3. So what is rate over A3؟ mole per liter second، وبعدين mole liter mole liter mole liter. cancel liter liter mole mole. What is the unit here؟ liter squared. حلو. mole minus 2 حلو. second minus 1 جميل جدا. كل دول هيدوا نفس الكلام، صح؟ this one will give me the same value because at the end you have 3 reactants, 3 and 3 reactants. So this is true. Doubling the concentration of reactants will increase the reaction rate by factor of 8.1 multiplied 10 to the power of 10. شو هالكلام؟
It doesn't make sense.
Doubling the concentration of the reactants will increase the reaction rate by a factor 8.1 multiplied 10 to the power of 10, which is a very strange factor that doesn't make any benefit. Okay. Right. Next one is, so the answer is D. Next one is the conversion of ozone to oxygen obeys the rate law. K is equal to O3, O2 minus 1. I hope that I'm recording. I'm not. Yes, I'm recording. So the conversion of ozone obeys the rate law. Rate is equal to K O3 to O2 minus 1. Which of the following statements is true regarding the rate of the breakdown of ozone into molecules? The catalyst that converts ozone to oxygen gas, oxygen is inhibited by oxygen. So I have here 2O3 gives me 3O2. And the rate law is rate is equal to K and O3 to O2 minus 1. Minus 1, we have never seen this minus 1 before. Okay, this is the first time. Let's see it. The catalyst that converts ozone to oxygen is inhibited by oxygen. يعني كل ما ازود او اغير الاكسجين الكاتاليست يبوظ. Doesn't make any sense for me. Nothing related للكاتاليست. طب the rate at which the ozone is converted to oxygen increases as the concentration of oxygen decreases. Oh, that makes a lot of sense because this is -1. So you want to say that instead of putting it to the power of 1, so when you increase the concentration, decrease the concentration of minus of oxygen, it's -1, the rate will increase. So it makes a lot of sense, can be true. This is an inverse square relationship between ozone and the oxygen concentration. Inverse relationship between ozone and oxygen concentration. There is no relationship between this one and concentrations at all. مفيش أي علاقة، ماليش دعوة بالconcentrations. I'm talking about the effect of concentrations on the rate. So it's not related at all. The conversion of oxygen to ozone is faster than the conversion of ozone to oxygen. No, he is speaking about the rate of the forward reaction بس. I didn't mention anything about the backward reaction rate here. So nothing mentioned about the backward reaction rate. The negative reactant order of oxygen indicates that the reaction is at equilibrium and the forward reaction is more favorable. Again, no relation at all. The answer is B. So the reactant orders can be positive, can be a fraction, can be negative. And when it is negative, what does this mean? It means that the reaction rate increases when the reactant concentration is decreased, the same that happened here. Okay. All of the following statements regarding the activated complex are true. What is the activated complex? This is the point at which you reach when you are in between what and what? Reactants and products. That point is what we called the activated complex. The energy of the activated complex determines the activation energy of the reaction. Yes, because the activation energy is equal to or more than this point. It's equal to or more than this point. You have to reach this point at least to make the reaction. The activated complex represents the highest energy state along the transition path of a chemical reaction. Yes, this is the highest point. You cannot be anything higher than that. The activated complex of a chemical reaction is specific to this reaction. It's specific to this reaction, yes. Configuration of atoms in the activated complex of an catalyzed reaction is the same as that of a catalyzed reaction, except for the presence of a catalyst. يعني ايه يا مستر؟ يعني the composition of the atoms in the activated complex, how they are. What is the activated complex? It's something in between the reactant and products. It's not a reactant, it's not a product, it's something in between. يعني the compound can break from this activated complex and make a reactant, or break and form a product. So it's like joining H with an H. Before you join and form the H2, it's like we are making something in between. This is the activated complex. So imagine it looks like that. You can either break down and make H and H again, or you can form the H2. So the configuration of these atoms in the activated complex of something that has no catalyst, uncatalyzed reaction, is the same that of a catalyzed reaction, except for the presence of the catalyst. الكلام ده, it's very wrong. It's very wrong, because what is the benefit of the catalyst? So
it lowers the active.
It lowers this one by making a pathway. كنا دايما بنقول عليهم في البيولوجي زي ما يكون كده يحضن الاثنين reactants يقول لهم تعالوا كده. What do you think? When you react in this way, it will become much easier for you. يبقى الاكتيفيتد فورم كاتاليكس الكومبلكس اللي بتعمل اثناء كيميكال رياكشن من غير كاتاليست لازم يكون ديفرنت من اللي بيتعمل مع الكاتاليست. البوتنشال انرجي نفسها بتكون ديفرنت، والكاتاليست بيعمل لي الترناتيف باث واي. معنى ذلك الانترميديت نفسه شكله بيتغير تماما. الانترميديت نفسه شكله بيتغير، زي يكون بيجيب كنبه كده ويقول للناس ايه سوفا please sit down here and try to react in a better way. طيب اخر حاجه reaction in which the energy of the activated complex is very large indicates that the reactants are very thermodynamically stable. صح، very thermodynamically stable as opposed to the chemically stable. طيب السؤال, so we have chosen D. The activation energy, okay, sorry. Which of the following is true concerning the reaction at 25 degrees? The reaction is endothermic. Is this reaction endothermic?
Yes. It's endothermic.
So this is the potential energy and transition from reactant. The reaction is endothermic.
Okay. It's exothermic.
بيقول لك أول حاجة إن الرياكشن endothermic. خلينا ناخد الجزء ده ونحطه كده، وناخد الجزء ده ونحطه هنا عشان يبقى حل أسهل. ده وهنشيل دي ونحط دي بس. The reaction is endothermic, yes. This is endothermic. The activation energy is approximately to equal to what? 510. مظبوط صح؟ طيب الماgnitude of the activation energy is approximately to equal to 510. مظبوط. This is the activation energy. The magnitude of the difference between the energy of the reactants and products is approximately 175.
Mister? Can you draw how it looks like when it's endothermic and how it looks when it's exothermic? Because I always get confused.
This is what I have when I have money. I have 100 dirham. I gained 300 dirham. So how much I am now?
300.
400. Then I lost 200.
So it became 200.
So it became 200. So this is exo, yeah, mister. This is exo. You lost more than you gained. You lost 300. So this one is exo. I made a mistake. This is exothermic reaction. It's not endothermic reaction. I made a mistake, sorry. And what about, mister, you gained 300. Mister keeps making mistake. You gained 300 and lost 200. You gained more than you lost. You are endothermic, you are right. Why wrong? But what happens when you gain the 300? So you become 400. And then you lost 400. You become what? 0. Imagine that this is the 0. Or let's make a number which is not 0, like you lost 350. So you become 50, صح? You lost more than you gained. You lost 350 and you gained only 300. Here you lost 200 and gained 300. When you gain more than you are losing, you are endothermic. The products are more. plus أكتر. And when you lose more than you gain, you are exothermic. So this reaction is endothermic, correct. Activation energy of this reaction is approximately 510. Let's see the numbers. Let's see the numbers. The activation energy is calculated by doing what? The energy of the reactants. Take care, there is too much difference between the activation energy itself, difference between the activation energy and the energy of the activated complex. Activated complex. We used to take this one in grade 10, صح? What is the difference between the energy of activated complex and the activation energy? Mister, this is the activated complex. صح? This is the energy of the activated complex from 0 into 510 equal to 510. It's called what? The energy of the activated complex. But what is the activation energy, Alain? This is when you are going from the reactant to the activated complex. So it's 510 minus 75 equal to how much? 510 minus 75, that's 435. So it's not correct, it's wrong. Tani, what is the difference between the activated complex energy and the activation energy complex activation energy? The activation energy is from the reactant till the activated complex. حتى فكرة, we used to say what is the activation energy of the backward reaction? From where to where? From the products to the activated complex. يبقى أنت عندك اثنين activation energies. One is from the reactants to the activated complex. This is the activation energy of the, it's called the activation energy. Let's draw it in the red also. The activation energy of the forward reaction. منين لمنين؟
From the reactant
to activated complex. ممتاز. What is the activation energy of the backward?
From the products to the activated complex.
ممتاز. What is 510 energy of the activated complex اللي هي from 0 until activated complex? This is 510. This is wrong. طيب, what is the magnitude of difference between the two differences, reactant and product? That's almost 75 and that's almost 250. So 250 minus 75 is 175. So that's correct. What is that known as? Delta H. That's what's known as delta H. We need to revise these parts. We need to revise these graphs. Okay? Just remind me next time on Wednesday to speak about this the graphs. Speak again about the multiple step reactions and to give more examples about this type of equation so that we get more confident in it. So the answer is 1 and 3. 1 and 3 and always E only. Which of the following is true concerning the effect of adding a catalyst? Activated complex would form is less than 40 seconds. Is this related to the previous question?
No, this is wrong.
So we don't have any information saying that it should form in less than 40 seconds. What is this, a medicine or what? Should work in 40 seconds? It lowers the energy of the products? No, has no relationship between. It doesn't lower this point. It lowers what? It brings the activated complex down. So it lowers the energy of the reactants? No, not reactants, not products. More reactions would occur per second?
Yes.
Yes. Because this is increasing the rate. The equilibrium would shift to favor the products? Not related. So the answer is only D. A reaction was observed for 30 minutes. Every 5 minutes, the percent of reactant remaining was measured. According to the data in the table below above, which of the following most accurately describes the reaction order and half-life? Mr. The reaction 0 half-life is 10. Mr. It was observed for 30 minutes. Every 5 minutes, the percentage was measured. According to the data in the table, which of the following most accurately describes the reaction order and half of the reaction? I feel there is something missing from this reaction. This is the question. Sorry. Is this related to this one? I have a feeling that this one is related. Questions are from okay, a reaction is observed. Let's take this one point. Observe it for 30 minutes. This is the one. So which one it describes? I can see that after 5 minutes, it changes from 100 into 75 after 10 minutes. So what is related? How can I find that order of the reaction and its half-life? How can I find the order of this reaction? It was 100, mister. When does it become 50 half? Almost 10 minutes, huh? Almost 10 minutes to become half. And then I want it to become half again. I want it to become half again. So from 56 into almost 28, it took 10 minutes more. And then I want it to become half again. So it took almost from 32 into 16, almost 10 minutes more. So it looks like it's changing its half-life every 10 minutes. From 100 into 56, almost, we can say like it's 11 minutes. And then again, 11 minutes, so it will become like from 56 into 28. And then more 11 minutes again, it will be again almost 16. So you can say that the half-life is
10 minutes.
10 minutes. So it is 0 order or first order. Is it 0 order or first order? We say that it takes almost between 10 and 15. It's not 10, it's almost between 10 and 15. And another one. This is now, if it is like that, then it will be first order. So this is the T half. This is the first order. T half is like that. It takes like equal times to change between, change between almost 50 minutes. Yeah, so it will be first order, and I can say it's almost, because it's not 10 minutes, right? Is it 10 minutes? Let's try to find it out. 10 minutes from 0 to 10. It's not 10. It's a little bit more than 10. You see, if it's 10, it will be 56 only. So it's more than 10, and it's not less than 10. So we can say it's either 12 or this 12, but it's not second order, it's first order. Okay, so it is B. Right. Next one, the rate law for the reaction between oxygen and NO2 is K equal to O2 NO2. This is the rate or the K. If the reaction rate is first measured with O2 and NO of 2.5, الاثنين 2.5 10 to the power of minus 4 reaction rate, by what factor will the rate increase if the concentration of O2 and O2 are both increased to 5 multiplied 10 to the power of minus 4? يعني عندي الريت لو بيقول لي O2 to the power of 1 when O2 to the power of 2. If the reaction rate، أنا مش فاهم هو بصراحة حاطط ال K هنا. I don't understand why he's putting K. So, okay. What did he change? He changed O2 and NO, both of them, صح? And this is first order and this is second order. By what factor will the rate increase if the concentration in both of them is increased? What happened to the concentration? It changed from 2.5 multiplied 10 to the power of minus 4 into 5 multiplied 10 to the power of minus 4. This is multiplying by 2. Right? Yeah. It's multiplying by 2. So the concentration is doubled. What is the rate of order of the reaction? It's first order to the first one and second order to the first one. So the total order of the reaction is 3. So this means it will be 2 to the power of 3. The concentration is doubled, so it is 2 to the power of 3. So it is 8. So it is 8. So the answer is 8. طيب. أنا عارف إن أنا طولت. I'm sorry, but consider the data shown above. If the data were obtained from a reaction whose rate law is K equal to X, what would be the expected rate of reaction for trial 2? If the data obtained X, what would be the expected rate of the reaction for trial 2? At trial 2, what is fixed? Nothing is fixed, صح? Formation of product is R. If the data was obtained whose rate law is K is equal to X. What would be the expected rate of reaction of trial 2? Is it R or 2R or 4R? The first one is how much is the order? First order. The second one is?
Second order.
Right. Let's see. The concentration of this one is decreased by half. So when you decrease the concentration of X by half and it is first order, so the rate will decrease by half. Correct?
Yeah.
And the second one, the rate is doubled. And it is second order. So rate is increased by what?
By 2 squared.
By 4 times.
4 times, yeah.
So you decreased it by half, you divide it by 2.
2.
And then you multiplied it by
4.
4. So this means you multiplied by
2R.
So it is 2R. A very, very nice question. I like it so much. Okay. Suppose the data were obtained for a reaction whose rate law is equal to kx squared. What would be the expected rate of reaction for trial 2? The same one. Questions 28, 29, 299 together. Data were obtained for reaction whose rate law is given. What would be the expected rate of reaction for trial 2? Let's just put the numbers. Can just
It's R over.
Huh?
Yeah, I got the answer. It's R over 2.
Okay. What did you do?
So since it's x squared, so it's half, so it becomes like 1 over 4, R over 4 basically.
So tell me slowly. K is equal to?
K is equal to R over 4.
R over 4.
Times 2.
2.
And then R is equal to K is equal to R over 2.
So K is equal to R over 2. No, I didn't get you. Can you just repeat from the beginning? You are trying to find this rate law. Suppose the data were obtained for a reaction whose rate law is equal to K equal to x squared. What would be the expected rate of the reaction for the trial 2? So what is the rate? This is K. You said x2 y, right?
Yeah.
And what would be the rate is equal to? I'm just wondering why he's putting the K outside here every time. Did you notice that? He's saying low and then he's putting the K on the other side. So I don't know what is the meaning of what he's doing. So rate is equal to kx squared y. Okay. So if we are following the same way that we are answering, what will be K? He is giving K. This is K. What would be the expected rate of the reaction for trial 2? Let's see. In trial 2, concentration of X is cut by half. We'll do the same thing. At X, the concentration is divided by half, like you said. Huh?
Yeah.
And in Y,
X multiplied by 2.
divided by half, and it is first order.
For X, it's second order.
It's second order, so it will be 1 over?
Yeah, 1 over 4.
1 over 4. And for Y, what happened to it? It is doubled.
So it just becomes doubled.
Become 2.
Yeah.
Then remove 1 over 2, so it is half R over 2, like you said. Sorry, I didn't get what you are saying at the beginning. I got confused.
I just did it fast, that's why.
It's what?
I'm saying I just did it fast, that's why.
Okay. The units, no, because you are good. Okay, the unit of the rate constant for a reaction that occurs between the two second order reactants is units of the rate constant for reactions that occurs between two second order reactants. So one is x squared and one is y squared. Most of them is okay. What is the units? Mole liter seconds, and then this is mole liter, 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 mole. So it is what? L
mole 1 as -1.
Let me get a second -1. So the answer is B. Correct?
Yeah.
Y is giving a different answer here. Let's try to do it again. Oh. This is repeated 2 times. Oh, not because we want to, doesn't mean that this is twice and this is twice. Huh?
Yeah.
So again, mole, liter. That's it. So it is L. ثواني كده. مول and مول ls لتر مول لتر مول لتر مول لتر مول. Okay, so مول مع مول لتر مع لتر. Correct?
Yeah.
So it is liter cubed.
Mole -3, second -1.
ممتاز. So it is D.
D.
Okay, that was a very good practice.